Notes 11a. Simplify radicals. Objective: I can simplify radicals. Essential question: how do I simplify square roots? On your notes foldable, you'll find a square that has a bunch of little squares with numbers in them. Pause the video and color these squares accordingly. 1 is neither prime nor composite. 0 and -1 are also not prime nor composite. So you will leave that blank. Color the blue, the numbers you see blue, color those blue, those represent the prime numbers. If it's prime, it's only divisible by 1 and itself. The orange ones are composite. That means that they have factors other than 1 and themselves. When simplifying radicals, check for the following factors: -1, 2, 3, 5, 7, or perfect squares: 4, 9, 25, 49. Those are for the square roots only. Or perfect cubes: -1, 8, 27, 125, and 343. Those are for the cube roots. So let's look at some examples. Let's start with the square root of 27. So we're going to look to see which of the numbers we could take out of the square root of 27. We're going to try our square roots. 4, 9, 25, and 49. Four doesn't go into 27. 9 goes into 27 though, so let's go ahead and divide out 9. 27 divided by 9 is 3. None of these numbers can go into 3 evenly, so we're done with that. The square root of 9 is 3. So our simplified radical is 3 square root of 3. Now let's do 18, the square root of 18. So let's try 4. 4 does not go into 18. 9. 9 goes into 18. We can divide by the square root of 9. That's 2. None of these numbers go into 2 evenly, so we're done. The square root of 9 equals 3. So our simplified radical is 3 square root of 2. Let's do the square root of 8. We can divide out 4. 8 divided by 4 is 2. None of these other numbers can be divided equally into 2. So we're done. The square root of 4 is 2. So we have 2 square root of 2. This last layer of the cake goes on the inside. The product of the outside numbers go on the outside. Now let's look at square root of -54. There's one more number that we could try to take out, and that's -1. We can take out a -1 here to make this a positive 54. We can also take out 9. 54 divided by 9 is 6. None of these numbers go into 6 evenly, so we're done. The square root of -1 is I. The square root of 9 is 3. So 3 times I is 3i. That goes on the outside. On the inside, we have our leftovers, 6. So our simplified radical is 3i square root 6. Let's look at the next one. 25x to the 6th power. So for this one, we want to separate out our square roots into two parts. The coefficient part and the variable part. Well, we know the square root of 25 is just 5. There's no leftovers. The square root of x to the 6th power can be rewritten as x to the 6 over 2 power. We write 2 because it's a square root. There's really an invisible 2 right here. 6 divided by 2 is 3, so we have x to the 3rd power with no remainder. So our simplified radical is not a radical at all. It's just 5x cubed. Let's do that for the next one. Square root of 90 is square root of x to the 5th. So 90 you can divide by 9. 90 divided by 9 is 10. None of these numbers go evenly into 10, so we're done with this part. Square root of 9 is 3. Now let's do x to the 5th power. We can rewrite that as x to 5 halves. That's not a whole number though, so let's do some long division. 2 goes into 5 2 times. 2 times 2 is 4. 5 minus 4 is 1. You have a remainder of 1. So that means that we have an x on the outside and we have an x on the inside. On the outside we have 2 of them. On the inside we have 1 of them. X squared, square root of x. That's x to the 5th. So let's put them all together. 3x squared times x, the square root of x. So our simplified radical is 3x squared square root of x. Let's talk about the parts of a radical. So here is our radical. This check mark looking thing is the radical symbol. Inside of that check mark is the index. If there's nothing there, it's implied to be a 2. The only numbers you'll probably see here is either nothing, which is a 2, or a 3. On the very left-hand side is this 5. That's the coefficient of the radical. That's how many of these radicals there are. It's the quantity of this radical. This 7 right here is called the radicand. It's the base when it's inside of a radical. And this 1 right here represents the exponent, the power. Like radicals have the same radicand and index. So if you're combining like terms, this number needs to be the same and this number needs to be the same. If they're different, they're not like terms. Let's look at this example. The cube root of negative 24n to the 5th power. So looking back from before, we want to try to take these numbers out. These perfect cubes. And we're going to separate the n and the coefficient again. So we can take out a negative cube root of negative 1. So now we have the cube root of 24. We could also take out a cube root of 8. 24 divided by 8 is 3. We can't take out any more perfect cubes, so we're done with that part. Cube root of 8 is 2. The cube root of negative 1 is negative 1. And this is our leftover. We have negative 2 cube root of 3. Now let's find the part with the variable. The cube root of n to the 5th can be rewritten as n to the 5/3 power. There's going to be a remainder, so let's do our long division here. So we have 1 remainder 2. So that is going to be n to the 1st power cube root of n to the 2nd power. Let's put all this together. So we have negative 2n cube root of 3n to the 2nd power. Now let's go back to square roots. Those are the ones that come up most often. 2 square root of 175. It's the same thing here. We're going to take out those numbers. It looks like we could take out a 25. 175 divided by 25 is 7. There's nothing else we could take out. So the square root of 25 is 5, and this is our leftover. So we have 5 times 2 times the square root of 7. That's 10 square root of 7. Now let's combine like terms here. 3 square root of 8 minus 2 square root of 18 minus 3 square root of 27. So if you look earlier in your notes, we have these already simplified. Let's plug those in. So from the examples before, we write down our simplified radicals. Let's multiply the 3 in. We get 6 square root of 2 minus 6 square root of 2 minus 9 square root of 3. Now we can combine these two terms because they have the same base, the same radicand, and the same index. 6 minus 6 is 0. So this is all you're left with. Negative 9 square root of 3. So we have negative 4 plus 2 square root of 2. That's the same thing as the square root of 8 from before, all over 2. We have negative 4 minus 2 square root of 2, all over 2. This 2 means we divide each of these terms by 2. Negative 4 divided by 2 is negative 2. 2 square root of 2 divided by 2 is 1 square root of 2. We'll do the same thing for this one. We have negative 2 minus square root of 2. When we have these two expressions, they can be rewritten. Plus or minus. This is the plus or minus symbol. Let's write that down. So this is the plus or minus symbol. That means two different expressions. So we have 5 plus or minus square root of 1 all over 2. Well, the square root of 1 is just 1. We can rewrite this expanded as 5 plus 1 over 2 or 5 minus 1 over 2. If we simplify these, we get 3 or 2. Let's do this one. 2 plus or minus the square root of 12 all over 4. Well, first of all, let's figure out what the square root of 12 is. For the square root of 12, we could divide out 4. 12 divided by 4 is 3. And we're done. The square root of 4 is 2. 2 times the square root of 3. That's what it is. So we have 2 plus 2 square root of 3 all over 4. Or 2 minus 2 square root of 3 over 4. Let's factor out the 2's for each of these to cancel them out. 2 over 4 reduces to 1/2. So we have 1 plus square root of 3 over 2 or 1 minus square root of 3 all over 2. Rational exponents dividing exponents.